Hi, welcome back to my channel. Today's presentation is about statistical analysis, and it's an introduction on statistical analysis in observational research. Well, this presentation is a part of a playlist on observational research. I invite you to watch previous videos. Don't forget that I am focused in this playlist on observational research as one of the families of quantitative research. Now, let me explain the objective of today's presentation. The main objective of today's presentation is to learn about statistical analysis in general and have an idea why we do it, what are the different tests, and to distinguish the different statistical tests. The content of today's presentation will be an introduction about statistics, what are the two types of analysis that we conduct in statistical research, what are the famous tests, how to validate our statistical results, and some takeaway messages. Let's start with the introduction and talk about statistics. Now, what is the purpose of statistics? Actually, statistics is a set of mathematical procedure for describing, synthesizing, analyzing, and interpreting quantitative data. It is also involving the selection of an appropriate statistical technique, which is determined by the research design or determined during the development of your research design, and you must have a hypothesis and you have data that you are collecting, and this means that by default we are working here about a theoretical approach of analysis. Now, when we ask ourselves why do we do statistical analysis, first answer comes in mind is first of all that we try to describe subjects, a sample, a population. We try simply to characterize it, describe it, understand it, better put it in picture. What we try also to do by conducting statistical analysis, detect any variance and detect differences in samples or in populations. Why this group is like that, why this population is like that, what is the variance here. We start based on the variance, compare the different populations, the different samples, the different subjects and their properties. And for sure, based on that, we can test different hypotheses. Only if we can manage to establish a correlation or an association, and we have a solid evidence on a correlation, we can after that even go further and start to do predictions. We can use regression analysis, for example, to predict and do modeling. And we can even, if we are very lucky and successful, to prove causality, meaning that there is an influence on a parameter, independent and dependent, and by that we can have a better interpretation and provide some insights on a causational correlation between one or different variables. Now, what is very important in our statistical analysis purpose and reasoning is that we should not expect that every statistical research will go through the 6 steps. In reality, it doesn't work like that. Sometimes we start our investigation, we do our observation, we collect our data, and we start to do the descriptive work, and then we do the variance, and then we stop with variance. Once we discover that there is no differences, the null hypothesis is proved. And this means that it is not always going 1, 2, 3, 4, 5, 6. Sometimes it stops on level 1, sometimes it stops level 2, and sometimes it stops with level 3. But it is very difficult to continue doing the analysis moving with the level 4, which is association and correlation, and more difficult to go with predictions, and very tough and lucky you will be if you can prove causality in your research field. So it's very important to be conscious about it, and to understand that most the statistical tests that we conduct are falling within those 6 categories, and we cannot go in every step moving to the following step without having sufficiently proven that there is a variance, and based on the variance, first we describe, then we do the variance. If there is a variance, then we can compare. If there's a comparison, we can study the correlation. Maybe it's positive, maybe it's negative. There is no correlation, there is only association. If there is a correlation, only then I can go with regression and prediction, and then maybe, if I'm lucky, if I'm able to use other parameters, have a better interpretation, maybe I can come up with a causality, but not every time it goes like that. Now, I talked with you about 2 types of statistical tests that are very famous and all the time used. We distinguish both of them, and you need to make choice from the beginning what type of statistical analysis you are going to do. First type is called the descriptive statistic. Here we are just using our statistical test to characterize, to describe our sample, and simply we are not doing anything in relation to the population sample. We are just focused on our sample that we collected, but the population we are far away. However, the second type of statistical analysis, which is called inferential, or in other words, parametric, in the inferential statistic, we are trying to also study the population and correlate the sample to the population. And here we are going to a more complex type of statistical analysis. So in a nutshell, we are talking about two types of statistical analysis, descriptive and inferential, or in other words, non-parametric and parametric. The non-parametric is the descriptive and the parametric is the inferential. In other, we can find those terms in other type of context. But at the end, we need to understand that one will limit us to understand our sample that we collected data about, and one will allow us to explore the relation between our sample and the population and characterize both, and maybe go further with the 6 steps I talked before earlier. Now, when we look at descriptive statistics, we are talking here about tests that are trying to measure location, that are trying to describe. We are looking here at descriptive analytics, that is looking at the process of using data to identify trends and relationships. Something like looking at the skew, at the mean, at the mode, at the median. This is what it entails when we talk about descriptive or non-parametric statistics, the type number 1. But when we talk about type number 2, which is the inferential, which is the parametric, here we are looking at establishing whether a certain relation between two variables is present, and we do it in a systematic way, and we try to even find a correlation or a causation. So this goes deeper in the analysis, and this also forces us to make a connection and bring us in relation to the population, not only the sample we are working on. So in this descriptive, we are very focused on our main sample, while in the inferential, we are focused on the sample and the population, and we are trying to also study systematically any relation between different variables. Now, what are the common statistical tests that we can say that are the most frequently used in practice and in literature? As you can see, I divided here in this graph the descriptive on the left side. Here it could be the mean, the mode, the median, the skewness, for example. Those are tests that are done for descriptive. They are maybe 4, 5, 6, 7, maximum 6, 7 tests. But when we talk about the inferential statistics or the parametric statistics, we have different approaches for tests. Some tests are seeking comparing one group to a hypothetical value. So here we can test our null hypothesis. Some groups of tests are looking at comparing two groups of people or subjects. Number 3 is comparing of 3 groups or more. The 4th types of statistical tests are looking to cluster and to allow for latent variable analysis. Then we can go with another group of tests which are related to the correlations. Here we find everything that is related to regression and correlations. And finally, we can have the last group of inferential statistical tests, which are the modeling tests. So allow me now to go one level deeper. When I'm talking about comparison of one group to a hypothetical value, I'm talking here about the chi-square test. I'm talking here about the t test. I'm talking here about the Wilcoxon test. When I move to the comparison of two groups, I'm talking here about the t-test, the mean-Whitney, the Fisher test as unpaired approach. And if I'm using paired approach, I'm talking about the t-test, the Wilcoxon, and the McNemar test. Moving to the third comparison of 3 groups or more, here we can also have unmatched or matched series of tests. For the unmatched, we have the one-way ANOVA, we have the Cruxell-Wallis, we have the chi-square test, and for the matched, we have the repeated measure ANOVA, the Friedman, and the Cochran Q test. Moving to the clustering and the latent variable analysis, what kind of test do we have there? We have the k-means, we have the two-step method, we have the factor analysis, and we have the multifactorial analysis. They all fall under the clustering and the latent variable analysis. Moving to the correlation, we can see the most famous three tests: the Pearson test, the Spearman test, the contingency coefficients tests. And finally, when we move to the modeling, here we are with the correlation and the modeling, we are able to investigate the correlation. We move with from another measured variable to from several measured or binomial variables. From the another measured variables, we have the simple linear regression, the non-parametric regression, the simple logistic regression. And under the several measured or binomial variables, we have the multiple logistic regressions. By that, this is the map for the different types and families of major statistical tests that are used. It's very important you understand every test is used in which context, and you need to understand then later on how to choose them, which will be explained in the following videos. Now allow me to move to statistical tests and their purpose, and allow me to remind myself and you about something very important. Like I mentioned earlier, there are key steps in statistical analysis. We start with description, detection of variance, comparison and testing hypotheses, establishing association and correlation, prediction, and proving causality. And not every time we can go all the step way down. Sometimes we stop at a certain level when we have null results, when it stops, when we cannot prove that our test brings significant results. But what is very important that we understand that we need also to be very cautious, because statistics is a wide and theoretical field that is strongly context specific and is highly biased. It can be easily biased. We can fool ourselves and conduct certain tests and manipulate the data in order to force the data in a certain direction. So therefore it's very important that we involve validation tests, and that we calculate the uncertainty and the error of our statistical analysis, and we need to involve teams of rivals. We need to be as much as possible transparent by doing pre-registration if possible, look at blind analysis that are the only way to avoid the misleading results, and work under these paradigms, and for sure look at the three principles of R. Make sure that as much as possible we are introducing randomization, replication or reproducibility, reducing noise. So, as you can see, blindness, replication, reducing the noise, and the randomization are the four very important criteria that we need to bring in our endeavor, in our research, so that we make sure that we are not going to be fooled, and we communicate every time we have any statistical results. We must always communicate the uncertainty, the range of error of our results, the confidence interval, to make sure and remind the audience and ourselves that results, whatever they are, that at the end they are theoretical and they might be prone to errors. Well, this is it of today's presentation, some takeaway messages for statistical analysis. First of all, I advise you to revisit relevant literature and avoid weak statistical tests, because statistics is always context specific. Make sure that statistical analysis of quantitative data can be driven by theory, probability, or data-driven approaches. You need to understand that, so the probability is so important to understand. And theory-driven analysis is geared by statistical testing of the hypothesis beforehand. So even when you want to start statistical research, it's not up to you. You need to first test your hypothesis, and based on the result, either you proceed or not. So the 6 steps I mentioned, they can be abrupted or stopped at any moment if you have negative results. So this is very important. There are 2 types of analysis. One is called descriptive and another one is called inferential, or in other words, non-parametric and parametric statistical techniques. And finally, check beforehand which technique is more suitable for your research Aim and always seek the reproducibility of your research methodology. Well, this is it of today's presentation about statistical analysis. Don't hesitate to watch previous videos and follow the coming detailed videos that will explain all these tests more into detail. This today's presentation was about statistical analysis. It was an introduction. Thank you very much for your attention.